Welcome, everyone. So I'm Kim Palco. I'm the product manager for big data in our Red Hat Middleware portfolio, and also specifically the JBoss Data Virtualization product. And so I'm here today with Alex Alexic from SAP. She's a product manager for SAP Hana and Smart Data Access, and also with Ted Jones, who is a principal engineer for JBoss Middleware. So we have a great presentation for you today. I'll be talking a little bit about the Internet of Things and what Red Hat has to offer there. Then Alex will talk about SAP, and Ted is going to give a live demo around a retail beacon, tracking consumer movements in a store and how all of these technologies can fit together to have a real-time response in that situation. So you've heard a lot about the Internet of Things and the fabulous demo that Burr Sutter did this morning in the keynote. And of course, the Internet of Things gives the ability for everyday objects from cars to medical devices, home appliances, to be able to send and receive data over a network. And there's a lot of speculation on how that might affect us in our daily lives and how it has already started to affect us. So, when devices start talking to each other, like the toaster and the refrigerator and things like that, a lot of jokes going on, but nobody's saying that, this time is not going to come. It's definitely happening now. And so, why this, why now? How did this come to be at this time? And there were a lot of different technologies and situations that came about to allow this, the Internet of Things to come to be. So explosive growth and connected devices, as we all know, ubiquitous internet connectivity along with very affordable bandwidth, and commoditized and standardized hardware, advances in cloud computing. All of these things work together to kind of create this perfect storm, allowing machines to be able to be connected and talk to each other and to us. So this is a diagram from Mary Meeker's Internet Trends in 2016, and it kind of depicts this, how the amount of data has been growing really rapidly over time. At the same time, the data infrastructure costs have been going down. So, more and more data coming across and a lot cheaper to be able to move it around. So where's all the data coming from? I mean, everywhere. Social media, as we know, and when you get the Internet of Things involved, then you can have things like medical devices, cars, wearables, and all of this is seen in the context of the reduction in cost and ubiquitous network connectivity. And businesses see this as a great opportunity. So there's a lot of economic gains to be made from machines talking to machines. There's new revenue streams. So the potential opportunity for like consumer products around the Internet of Things is really astronomical and kind of unknown right now. It's really evolving space right now. Of course, efficiencies and productivity. I mean, if I just think about my own smart meter in my own home, somebody doesn't have to drive up and take the level of how much electricity that I've used. It all saves a lot of manual effort. And so at the center of all of this is data. So a lot of data coming from these devices. And data is really just the raw material. It really doesn't get any value until you can be able to analyze it and get some insights from it. And the raw data itself from these sensors is also really, the value is obtained when you're able to combine it with the information that you have in your data center already, in your traditional systems. So for example, if you have someone in your retail store looking at someone, you would want to know their history. Are they a customer? Maybe what have they bought? And Ted's going to be able to talk more about that in the demo. So where does Red Hat fit into all of this? So we're going to, in just a moment, go a little more deep into the technology of the Internet of Things. But overall, Red Hat brings its, the same open source value that we bring to all the other technology here. So we're open, not only in the sense that the code is open, but also that we don't lock you into any one proprietary solution. As well, we are able to capture all the innovation in community around IoT and big data. And a lot of that is going on in open source. Okay. So this slide, I'm sorry, it isn't showing up as well as it was when we practiced this. So I think I'm going to move, let me see, just a moment here. So what essentially this is showing is we're looking at like a three-tiered architecture. So you have your devices at the edge, there's sensor devices. So when I think of sensors, I think of like the 5 senses, but for machines. So instead of tasting and touching, they're measuring things like light, noise, temperature, blood pressure, all of those types of things. So you've got your sensor devices at the edge, and you have your data center at the back end, and in the middle is an intelligent gateway. So this gateway is necessary. Traditionally, a gateway like this would just, say, translate protocols from the edge to the data center. But now with the massive amounts of data coming online, it needs to do much more than that. So what we offer at Red Hat is an intelligent gateway that's able to filter some of the data that's coming through, as well as to be able to even analyze and make decisions right at the gateway. So if I gave the example of, let's say, building operations. So you could have, say, a company could operate, say, millions of square feet of buildings. And they can actually do it remotely with sensor devices. And all of that data could be overwhelming if it all went back to the data center. So what an intelligent gateway allows you to be able to do is to be able to filter. So kind of just the normal data doesn't get through if everything is fine. But in addition to that, the gateway can make some decisions itself right at the gateway. For example, if the temperature of the building is off, it can kick on the air conditioning or the heat and adjust it right there without having to go all the way back to the data center. And that's what an intelligent gateway is. So at Red Hat, what we put on our intelligent gateway is some of our middleware technologies. So starting at the bottom in this diagram, we have the Red Hat JBoss A-MQ messaging system. And that can actually talk to sensor devices through protocols like MQTT or AMQP and transport that data to the gateway. And then also JBoss Fuse to be able to do some transformations on that data. And JBoss BRMS, which is our rules engine. So all of those can run in a very small footprint, very close to the edge. And with the JBoss rules, you can make decisions. And actually, I gave the example of the temperature control. You can do that right there at the gateway without having to send the data back to the data center, saving a lot of network bandwidth and time. And so then again, the data that does get through to the data center, which is a massive amount of data. I was really kind of impressed when Cisco in their keynote yesterday said they anticipate that each one of us will be transmitting 1.5 gigabytes of data each by the year 2020. It's kind of unfathomable. And how does that data get integrated in the data center? And so that's what we're going to be talking about for the rest of the presentation. And in JBoss Middleware, we kind of focus our big data strategy or anchor it around our JBoss Data Virtualization for that reason. So back in the data center, there's all kinds of data sources. It's not homogeneous. There's new data sources coming online all the time. NoSQL sources, Hadoop, social, and of course, the Internet of Things. And you end up with a bunch of siloed systems and building applications very rapidly under tight deadline pressure ends up with a point-to-point kind of data architecture. And so, it's a very brittle architecture. There's a lot of data sprawl, a lot of data copying and movement. And the existing integration approaches, again, they are very brittle in case you need to make any changes. And every project accesses data in a different way. So there's not any reuse among the projects. And so what we would like to see is a cleaner diagram where any of these, or a cleaner architecture, where kind of in a similar way that an ESB solves the point-to-point integration problems for applications, you can still have kind of a spaghetti point-to-point architecture underneath with the data sources. And what data virtualization allows you to do is kind of create this abstraction layer in the middle of, so that all of the connecting applications can connect to this layer and the consuming applications, and the data sources can kind of be plugged in. So the Royal Bank of Scotland did a presentation yesterday, and they actually used data virtualization across their global bank, and they were in they talked about a situation where they were acquiring different banks as merging, selling some things, and they said that they think of this architecture, their data access layer using data virtualization as kind of a plug and play, where you can just plug data sources in as they come on, and also plug in new consumers as people request, say, a new analytics system, Tableau or Click or Looker or whatever. And they said, RBS was saying that it would have taken them months and months had they used traditional ETL, where data virtualization added such a lot of flexibility. So how does that work? You could have a REST request that is translated into REST or SQL statements or whatever works with the consuming sources, and then the result comes back up, and I'm sorry, but this isn't working exactly as planned here. The results will come back up to the consuming application in the protocol that it is expecting. And so, I'm here today with SAP, and one thing that we're going to be really highlighting is the integration with SAP Hana and data virtualization. So what we're able to do with our data virtualization product is to be able to connect to SAP Hana as a data source. Also, our virtualized database can be a source to Hana. In addition, we can also cache data, virtualized data to Hana as well. So 3 different ways that we'll be using it. Ted is going to demonstrate one of them, but I did want to let you be aware that all 3 is possible. So the way to look at this diagram is from the bottom up. You have multiple different heterogeneous data sources. You can connect to those. Compose your own virtual database, picking and choosing exactly the fields that you want, the data you want from each of these different kinds of sources, and then being able to expose that in any way. For example, OData, very popular standard specification for sending data across REST. It's supported by SAP, Red Hat, IBM, Microsoft, other major corporations. So OData, REST, JDBC, ODBC, and you can reuse those models as well. And in addition, we provide designer tools, dashboard. We spend a lot of time on our performance optimizations. We have a recent performance study that's out on redhat.com if you want to see that, and as well as centralized security. And that's a big thing because all of these data sources are not created equal in terms of security. And so you can be able to apply that security at the centralized level. Okay, so there's, yeah, I'm sorry, I don't know, we tested these slides before we came here. But anyway, there's a lot of key benefits in terms of return on your assets. So people have, yes, if you could just all lay down sideways and you can read the slides, so I apologize for that. Return on assets. People have, companies have a lot of data in their organization that they're aware, like the people that I talk to, customers I talk to, aware of data that has a lot of value that's sitting in siloed systems. And you know, with they just don't know how to get to it. With something like data virtualization, you can access all those systems and to be able to combine them very easily, as well as, you know, the agility that you get from having a data access layer and not having those point-to-point connections, productivity benefits like RBS saw, and your better information control like I was talking about with security. So with JBoss Data Virtualization, we support a wide number of data sources. If you have any that are not here that you want, we also ship with a custom, a kit to make your own custom adapters and connectivity. And we're adding more sources all the time, particularly in the areas of, of big data and, NoSQL and some of the newer sources that are coming. And so, data virtualization is part of a data pipeline. And so, I just wanted to talk a little bit about this before I hand over the presentation to Alex. But what we see is that the time to decision is shrinking, and that we really can't have siloed data anymore, that the actual data and analytics are required to be part of the application now. So there's kind of a new breed of application. It's something Mary Meeker calls the third wave of data applications. And we have a lot of technologies at Red Hat to be able to address these. We're talking about some of them today. We also integrate with other technologies like Spark and Hadoop to be able to deliver these new type of data pipeline. And we'll be talking more and more about data at Red Hat as we go forward, because the Internet of Things and big data is really requiring that applications be able to run analytics very, very quickly. And with that, I will hand it over to Alex. Thank you.
Hi, I'm Alex. I'm from SAP Hana Product Management, and one of the main topics that I cover is SDA, but before I get into that, it's a Smart Data Access. It's the data virtualization that comes with the core HANA. But before I talk about that, I'm just going to go over a little bit about what HANA is for those of you that aren't familiar with SAP HANA. Just our standard disclaimer here, just to not rely on anything in this presentation. This image is a little funky, but so what's the issue that really inspired HANA? So you have all this data coming from these various transactional systems, and as you can see from the diagram, you can have multiple systems in your environment where you have different sets of transactional data. And if you want to do analytics on this data, you end up replicating this transactional data into these different databases where you're doing analytics on it. And it's an extremely time-intensive, labor-intensive process that introduces latency into your business. So it could You could be perhaps even doing reporting on old, outdated data, which isn't the standard now with our new digitalized world. So the goal with HANA really is to be able to remove this latency and decrease your total cost of ownership, in the sense you don't have to administer all these databases, you don't have to go through all these labor-intensive processes, and really streamline how your business runs and make it run a lot simpler than ever before. Wow. Okay, so you have the old system, pre-HANA, you have all these different sets of data feeding into all these separate applications. So the data is extremely siloed. And with HANA, since you can have OLTP and OLAP data in the same place, you can really combine all these data. You can combine all this data into a single platform for all your applications in one place. So you're not having to do all these extract, transform, load processes. And you're really, you're not having to wait for data access and processing, and you can process all kinds of data just in this one single system. So it really is a lot faster and a lot more simple. And it really allows you and your business to focus on innovating rather than how to manage data in all these separate systems. And it really decreases the latency to the decisions, the critical business decisions you need to make for your company. So the HANA platform is really a foundation for modern applications. So there's a huge amount of functionality packed into this one platform. So I won't get a chance to talk about all of it today, but I'll just highlight a few of the key points. We have application services available. So we have a great new Fiori user interface. So just a super intuitive graphical interface. Then we support spatial data, graph functionality. We have predictive analytics built into the platform with a huge predictive function library, application function library, excuse me. We do support also text analysis, we have a very sophisticated text analysis capabilities to allow you to do all kinds of searches on text data. Then we have a variety of also integration and quality services, so all kinds of data virtualization capabilities, connectivity to Hadoop data, and quite a few database services in general as well. So we have advanced compression to reduce the data footprint. We have multi-tier storage for hot and cold data. And one of the things that we're really proud of is that we're open. So you can use HANA with all your preferred products. So for example, like in the demo today, we're going to be showcasing the integration with JBoss and Red Hat functionalities. So we allow you to customize your environment to whatever suits your business best. And we really have so many applications on our platform, and that's something that we're really proud of. So we have, I believe it's over 3,000 startups and ISVs building applications on our platform. And it's a really simple consumption model because all the data is residing in one place, and you can access all your business data within HANA. And this allows you really to rapidly commercialize your innovation because you're not having to extract data from different data sources to build applications on HANA. You can build data location agnostic applications just right on this one platform. So HANA, we have a bunch of different products built around HANA. So at the core of it really is the SAP HANA platform. So you can have that on-premise, but we also have the SAP HANA Cloud platform, and we support hybrid environments as well. We have a next generation business suite, S4 Hana. And we have various IoT applications, so you can do things like predictive maintenance, which I know Kim was talking about also. And we have Hybris as a service, and a variety of other really great applications and services all within this one platform. So you can customize it really to suit any business environment and any business need. One of the things that we're going to be focusing on a lot today in the demo is the integration services within HANA, and specifically SDA, so Smart Data Access, which is the data virtualization, one of the data virtualization components within HANA. So you can really, via data virtualization, you can access data from different systems while the data stays in place, so you're not actually transferring any data, which really enables you to build applications extremely quickly. So now I'll talk a little bit in a bit more detail about Smart Data Access. So the issue that really inspires data virtualization is that customers have a heterogeneous system landscape. So you have data stored in all kinds of systems, which I know we've already talked quite a bit about. And so you want to be able to have a really cost-efficient, easy-to-deploy solution to access data across these different systems. And really the intention here isn't data that hundreds of users are going to be accessing every single day. This is more a solution for an ad hoc data access. So with Smart Data Access, you can quickly and easily access this data and achieve virtualized access to it with very little cost to the customer. So it's a quick and effective way to access data stored across all these separate systems. And what's great is that it's applications built on HANA view this data as location agnostic, so you don't have issues there when you're building applications. And some of the key functionalities that are available in Smart Data Access include the federated query processing, and there's no special syntax to access these remote data sources, which is really great. And you can really benefit from HANA functionality without moving all of your data into HANA. So there's cost savings and cost benefits there because, of course, it's expensive to store all of your data that you don't necessarily need all of the time in memory. So this allows you to benefit from that without actually loading all your data in HANA. And of course, one of the key benefits here is the rapid deployment of the high-performance applications. And I just wanted to touch a little bit on the concept of the virtual table, because that's what the functionality of SDA centers around. Sorry, this image is pretty funky too, but so you have a virtual table in HANA that points to a remote object in a remote data system, and no data is actually getting transferred. You're just seeing the metadata. And what's great, which I already mentioned, is that the applications built on HANA don't treat this table any differently, this calculation view any differently than other tables in HANA. So it's really, they're blind to it, which is great because it simplifies the process for the developers. And I know these slides will be made available to you. So if you're interested in learning more about SAP HANA, you can find a lot of links on the public web pages available at sap.com. And we have a ton of great HANA Academy recordings on YouTube. So they're totally free and great instructional videos to get you started working with HANA. And that's all from my side. I'll hand it over to Ted, who's going to talk about the demo.
Thank you, Alex. Let's see, there should be another slide here. Okay, so we've been working on this demo for about a year now with SAP. This is one version of the demo where you have your IoT gateway, we're pushing to the cloud platform, and then federating sources and data virtualization. That's not the one I'm going to show you today, though. So this is the one that we're featuring. So the IoT gateway box, you see the rectangle there, is a standalone retail store, so that the gateway lives in this remote retail store. We have IoT beacons, which are actually the mobile app you see at the very top. So the customers for our fictitious store, which we've called Joel's, have downloaded this app, and we're tracking their movements through our store. So we can tell what departments they're going into and where they're going. So the beacons, it's a Python script running to emulate this data. So the Python script is sending messages to A-MQ, which is our message broker, over MQTT. So there's 3 topics published by the beacons: customer enter, customer move, and then customer exit. In addition, we have a business rules management system set up on the gateway that has a couple of rules defined in it. Specifically, is a customer focused in a certain department? If so, we're going to put another message over MQTT back on the queue. And also, if they're moving around rapidly, we're going to put another message because they're categorized as roaming, right? So these are 2 types of customers that may need assistance. So we're going to put these messages on the broker, and then our web UI will actually read that data. It'll show the customer positions in the store, as well as alert the customer salespeople of these of the customers that may need assistance. So I think I'm going to switch to mirror my screen. It'll be a little easier to show this demo. Okay. There we go. Okay. So I mentioned the web UI. This is the web UI in action. It's a simple HTML5 page with a Node.js module that is subscribing to our message broker and pulling back all those messages. So you can see that the customer is being redrawn as new messages come in, showing the customer location. And then you also see the alerts that are going to the salespersons. There's a lot of alerts. This is a demo, so we kind of generated additional data, more than we would normally. I believe every 3 movements within a department, we consider that customer focused. So that's why you see all those. And then I mentioned that BRMS is capturing this data and determining if a customer is roaming or focused, right? So that's where the filter that Kim talked about comes in the intelligent gateway. So the rules engine can be used to kind of filter out the noise of all those additional messages that aren't really meaningful necessarily. And it can insert that data into SQL Anywhere. SQL Anywhere in this demo is exposing 3 web services. So we can insert into those web services directly from BRMS based on the decisions that we've made. So this is the gateway, this is the store, this is all remote data, but eventually we would like to push it up into the cloud, right, to process it. But you don't always have enough bandwidth necessarily, or you don't always have internet connectivity, so that's not always possible. But when it is available, we use something called SAP RD Sync. It's remote data sync. It's part of the HANA cloud platform. And SQL Anywhere, if you're familiar with MobiLink from SQL Anywhere, that's what RD Sync is. So you can push that data from the remote SQL Anywhere instance into HANA. We also have a second HANA instance, SAP Hana 2, and that has inventory for all the stores in the Joel's corporate organization. And then we use Smart Data Access to access that second HANA instance. So we're going to virtualize that store inventory in HANA 1. So then if you look down at the bottom, we've got 3 other data sources. We have a Postgres, which has sales history for customers. We have Salesforce, which has our customer data. And then Amazon Redshift, which has promotional information like sales for the store. Amazon Redshift, if you're not familiar with that, it's Amazon's data warehouse. So we're going to federate all of that data into data virtualization. And this is where it gets really heavy. So we're not moving data either in data virtualization, right? We're just virtualizing that data. We're going to connect to HANA 1 using Smart Data Access and virtualize that virtualized data. So think about that for a minute. That's right. So now we have all of our federated data in HANA, and we want to communicate with our mobile application. So we talked about OData, OData being a RESTful protocol. It was put forth by Microsoft initially. SAP adopted it for their SAP Gateway platform. Red Hat has embraced it as well, and it's now an OASIS specification. And we both collaborated. We're both on the technical committee for OData and helped to shape the version 4, the current version of OData. So you can expose all that data from HANA over OData URLs. And then your mobile application can read that data in. So I'm just going to switch over. We've got, looks like my emulator has stopped, so I'll restart it. So we've written a mobile app for our fictitious store, Joel's, that's going to consume data from all the different sources you've seen on here, and all out of the first HANA instance. It takes a minute for the emulator to start here, so it'll just be a second. I also want to mention that, as I said, we also support at Red Hat OData. The Red Hat JBoss Data Virtualization engine serves as an OData client as well as an OData server. So we could also expose the federated data that we have in data virtualization to the mobile app as well. Okay, so here's our app. You see the different departments that matches the IoT demo diagram that we had. So that information, the department information, is coming from HANA 1. And we can drill into that, and we'll see, for the boys department, we can see the sales. So that's promotional data coming from Redshift. And then I can filter on that information as well, look at different departments. And I can get to promotions directly from there. And orders, so we have sales history, we have customer data. The sales history is coming from Postgres. The customer data is coming from Salesforce. And all of that is being realized in our mobile app via HANA. And then you can set settings here. We also have a place where you can set your store, so your home store, your favorite store. And that information is coming from HANA 2. So all that store data is stored there. And then you can switch it out if you want. You can enable or disable notifications, and I'll talk about what we're doing with notifications in just a sec. And then you can set the interval on that. And then contact us, standard stuff. So the real power of this demo is what we're doing with the notifications. So we know where the customer is. We know who they are in our store. We know what department they're in, and we can also tell their sales history. So based on all that information, we can pick a promotion targeted to that customer and send them a notification. And that's what we've done. So we've identified that this person is in the girls department, and they purchased pajama pants, which we just happen to have on sale for 31%. So we can make an intelligent decision based on all of this data, the IoT data, the data in all these federated sources, and target a promotion for this particular customer that will have a better likelihood of making a sale. So while this architecture is, and this demo is geared towards retail, this is a design that can really cross industries. This could work in transportation, oil and gas, manufacturing. So you can take this architecture and implement it in one use case in your company and use that as a blueprint for other IoT use cases. So that's all I have for the demo. Any questions? I've got 2 more slides to go over. Any questions about the demo here? I do want to mention it's on GitHub. So I've got a repository called JBoss SAP Integration, and this particular demo is called IoT Demo JDB. You can go out, you can clone this repository, and the mobile app is there as well, and you can try this out yourself. So let me switch back to the slides here. So this kind of summarizes all the different technology that we use in that demo. Of course, we had HANA and SDA, so SDA was consuming data virtualization, also connecting to HANA and virtualizing all that information. RD Sync, which is critical to this IoT use case because you need a way to get it into the cloud, get that remote data into the cloud. SQL Anywhere, it's a really powerful, lightweight database. It's perfect for this IoT gateway or intelligent gateway. SAP refers to it as the intelligent edge. And then A-MQ, the message broker, you need some way to hold on to those, queue up that data. You get a lot of data. And then because you get a lot of data, you need a way to make smart decisions about what data really makes sense, what data do you care about, what data do you want to push into the cloud to make your informed decisions. These are all the presentations that we've had related to data virtualization, and I just want to point out a couple. Anything that you've missed, you'll be able to get the slides for, and I guess others were recorded as well. So the Think Differently with Real-Time Data, that was RBS, the Royal Bank of Scotland. They were a customer of ours, and they did a great presentation and very, very interesting use case. And then, let's see, what was the other one? Which other one did you want me to point out?
Well, there's also the one that was opposite us today is Red Hat IT. So Red Hat IT is facing a lot of issues that we were talking about today, not necessarily with IoT, but just, you know, they said that they get a request for a new data source every couple of weeks, or a new data source or table or consumer every couple of weeks. And so they talked, it's been opposite this talk, about their journey and how they're using Red Hat technologies to solve problems within Red Hat IT. That's a great one. And then there's also tomorrow, I'll be doing a presentation with the JBoss Data Grid product manager, and we'll be showing a live demo. It's also IoT related around a medical healthcare use case, and it's combining JBoss Data Virtualization with our high performance scalable data grid and also Apache Spark. So wanted to call that one out tomorrow as well.
And also, you want to talk about the party?
Yep, the party tonight. So hope to see you there. And if you don't already have your invitation, then stop by the Red Hat booth in the partner pavilion and pick one up. First come, first serve, so be sure to get there early.
I've got an extra one
Yeah.
if someone needs one.
Yeah.
Okay, that's it.
All
All right, any other questions or comments? No? All right, well, thank you very much. Appreciate it.
All right, thank you.